Hi, everyone, and welcome back to our series involving online interviews of the main partners from the NEUREKA Consortium, where they get the chance to tell us a little bit about their expertise, as well as what they contribute towards this multinational, multi-institutional project. So what is NEUREKA? Well, NEUREKA involves an innovative hybrid technology where nanoelectrodes and sophisticated computational models of neural networks are combined to obtain readout and then manipulate activity and connectivity in cultured neuronal networks modeling Alzheimer's disease. My name is Dr. Pravina Managaran, Senior Scientist at Maxwell Biosystems, and today I'll be interviewing Professor Guilhem Larrieu, Director of Research at LAS CNRS in Toulouse, France, where they're leading activities on nano and neuroelectronics. He is also a research fellow at the University of Tokyo in Japan. Welcome, Professor Larrieu. How are you doing today?
Yeah, pretty good. Yeah, thank you.
So I'd like to begin the interview by asking you to give us some details on your own background and expertise.
Okay, so basically my background is on applied physics and material science. I'm working for more than 20 years on intimate nanoelectronics by developing even smaller and more efficient transistor device. And about 7 years ago, I opened my research activity towards development of nanostructure device for electrophysiology of excitable cells like neurons, but inspired by the tricks of silicon nanoelectronic processes.
Cool. So, what is the main role of your lab in the NEUREKA project?
So our main contribution is the development of this nanoelectrode array technology. So nanoelectrode is composed by vertical metallic nanowire, about 5 micron long, that allow a higher affinity with cells, and thus a much more resolute capture of the electrical signal it generates. And our core technology is composed by 60 nanoelectrodes in parallel, as well as associated electronic measurement system. And in parallel, in the framework of NEUREKA, we are trying to co-integrate this technology on the CMOS technology of Maxwell Biosystem in order to reach very high density of nanoelectrodes.
So, what are the main contributions of the NEUREKA project that will advance your specific field of research?
Yeah, clearly the stimulation of neuronal culture with nanoelectrodes, because up till now we were mainly focused on optimization of the recording performances of the neuronal electrical activity, and the focus on stimulation now open new interests, both I would say at the fundamental level as engineering of the nano interface characterization, as well as applicative level, in particular the very localized stimulation of subcellular compartment of the cell, and also the use of computational protocol of stimulation.
So, how many researchers are involved in your group, and what are their specific expertise?
So in this project, I have 2 excellent young researchers. So Ines, a PhD student working on the optimization of the technology for the stimulation, and Azilis, which is postdoc researcher, on the deployment of our technology on the CMOS platform of Maxwell Biosystem. And on the top of that, we have also a very strong support from the LAS technical staff, with in particular Fabrice and Franck, who developed the electronic part to drive the platform. We have also Charlene and Maël, who manage the bio part and the neuronal culture on the chip. And finally, Laurent and Aurélie, who manage the work in clean room, so about micro and nano fabrication.
Great. So, NEUREKA is an interdisciplinary project across Europe. Can you elaborate on the impact that the project partners have on your research?
So yeah, indeed, NEUREKA consortium is very diverse and at some point very complementary, with people from material science, neuronal interface, neuronal computation model, and also inside academics and SME. And this high quality interdisciplinary consortium definitively fits each group of researcher, I think. And in my particular case, the work with neural interface specialists allow us to understand our technology with more finely. And also, of course, the very sustained collaborative work with the Maxwell Biosystem allow important advance on this type of technology, for sure, but also to address more general questions in nanoelectronics, such as monolithic integration of device on CMOS technology.
Great. So is there any general remarks, project outlook for your work?
I would say yes, for sure. It's a pleasure to work in such a consortium on a daily basis. And I hope this project is a beginning of a beautiful journey toward new approaches for biosilicon interface.
Mm-hmm. Great. And finally, do you have any sort of social media that you wanted to shout out or any final remarks?
Yeah, I want just to say, if you are a motivated young researcher or PhD student or postdoc, if you want to join this adventure, just feel free to contact me.
Great. So thanks again for sharing everything about your work, and we look forward to hearing more about your project in the future.
Yeah, thank you very much.
Thanks, and bye.
Bye-bye.